charge tape. Of this lab report is to delve into the concept of force fields, such as electric fields, by studying the interactions between two electrically charged objects and the force that they exert on each other. After this report, one should fully understand how charged particles interact with one another and be able to quantify, using formulas based on proved theorems, the magnitude of the electric field created by a particle of known charge. Tell us that the value of the charge on one tape is 5.60286 times 10 to the negative 9 coulombs. This total positive charge is consistent with the experiment that we conducted between the two charged tapes, as it proves that they are both positively charged and thus repel each other as expected. In summary, this lab gave us insights into the relationship between electric force and gravitational force. Charged particle can be defined as the product of the charge and the net electric field at the location of the charge. Electric field, on the other hand, can be defined as a region of space around an electrically charged particle, where an electric charge will feel a force. Its units are Newton coulombs and is given by a formula below. Induce a charge on a typically charged neutral object, and it is called electrostatic induction. It is the redistribution of electric charges in a previously neutral body caused by the influence of nearby charges. If in this experiment, our neutral bodies are pieces of Scotch tape, which gains a positive charge due to swift physical interactions with the table and other tape pieces. To proceed with this lab report, we must first clarify that some assumptions were made while collecting data. We must assume that the atmospheric conditions, that is the humidity, are appropriate for the conduction of this experiment. We must assume that there are no additional external electric forces which may influence the interaction of our charged tapes. Additionally, we must assume that the mass of a Scotch tape is 1 gram per meter, and we must also treat the tape as a point charge with all the charge concentrated at the center. We must assume that each tape has the same amount of charge. Lastly, was performed by recording the interactions between two charged pieces of tape, which we created by laying down a base tape, a top tape over it, and swiftly ripping the top tape off the base tape, which creates an induced charge at the top tape. Once we had created two charged tapes of equal lengths and masses, 0.2 meters and 0.0002 kilograms respectively, we observed how they interacted with each other as shown in the photo and measured the displacement that occurred due to repelling electric fields. Completion of the lab zero starter code. Acquiring the necessary results was simple. Firstly, I assumed that the gravitational force and the electric force were of equal magnitudes, which held the body in equilibrium. I calculated the force on one tape to be 1.92 times 10 to the negative 3 newtons using the Newton's second law formula, F is equals to mg. I then equated this to the Coulomb's force formula as seen on the code, taking the measured values between the tapes 0.012 meters as our distance d. This gave me a value for the charge on one tape to be 5.60286 times 10 to the negative 9 coulombs. Earlier, I had listed out some assumptions made in order to proceed with this analysis. These assumptions can also be presented as sources of errors. Thus, our total sources of errors are assuming perfect atmospheric conditions, assuming both tapes had the exact same charge, and human error, such as parallax error when taking measurements. Charges of the tapes were flipped. That is, the positively charged tape becomes a negatively charged tape. The results of the experiment will remain the same. This is because like charges always repel each other, regardless of the type of charge. Thus, there will still be a repelling force between both tapes. However, when the charged tapes encounter an object like a hand, they could possibly lose their charge, as human skin conducts electricity, and if the tape loses its charge throughout the experiment, then that could interfere with the data and possibly skew our results. Thank you so much for listening to my lab report. Have a lovely